Plant hormones, also known as plant growth factors, are chemical substances that accelerate, inhibit, or otherwise affect growth. This animation explores the action of indole-3 acetic acid, IAA, the most common form of auxin, and looks at how we discovered what auxins do. The auxin IAA is produced at the apex of the stem. Under unilateral light, shining on one side, IAA is redistributed to the shaded side, creating a gradient of the hormone across the stem. IAA travels between cells by diffusion. IAA activates proton pumps, which lowers the pH. This activates enzymes, expansins, to break bonds in the cell wall. The loosening of the cell wall allows water to enter the cell and turgor pressure increases. Cells on the shaded side become elongated and cause the shoot tips to bend towards the light. But what is the experimental evidence for this? Darwin investigated using oat coleoptiles. He found that there is no bending response to light when the coleoptile tip is removed. This means that either the tip is the origin of the messenger, or it must be stimulated by light. To investigate further, Darwin covered the tip to prevent light from reaching it. The lack of bending response confirmed that the tip must be stimulated. When light was shone on the tip but the lower regions were covered, the coleoptile did bend. This showed that only the tip needs to be stimulated. Peter Boysen-Jensen used a thin flake of the mineral mica, which blocks chemical movement. When it was inserted in the illuminated side, bending occurred normally. But when the mica was inserted in the shaded side, there was no bending, showing that the message to bend travels down the shaded side. Because the mica doesn't block electrical signals, this also suggested that the message was chemical. Arpad-Pal's experiment, replacing a segment of the tip off-center, increased understanding of how the hormone is distributed. Even in the dark, the coleoptile bent towards the side without the tip. Fritz Wendt removed the coleoptile tip and incubated it on a block of agar. The agar was then placed on the coleoptile off-center in darkness. Hormone that the agar had absorbed travelled down the side of the shoot, causing a response. The amount of bending is proportional to the amount of hormone in the agar. Winslow Briggs inserted a very thin glass plate vertically through the tip. The glass does not prevent light transmission, but there was no bending. Auxin cannot travel through glass, and its concentrations remained equal on either side. When the glass plate was inserted below the tip, auxin moved across to establish a hormone gradient. When the tip was examined, 70% of auxin was found on the shaded side.